Good morning, everyone. We're going to have a very interesting session today, talking about our favorite subject, artificial intelligence, that's been in the news for the right reasons, AlphaFold and a few others interesting developments like DALI, but also for the wrong reasons, with Elon Musk and others that try to vilify it. But today we're not going to go in that direction. There is a session with myself tomorrow morning where we're going to touch the big Elon Musk subject. But today we're going to talk about AI in business. And with me, I have two heavyweights, superstars when it comes to AI. Lila Tretikov, Deputy CTO Microsoft, and Jacomo Corbo, co-founder and chief scientist at QuantumBlack. Welcome, guys.
Delighted to be here.
Thank you for having us.
And let's delve straight into the subject. Besides AI, the last few years, we've been very busy with the climate change topic and trying to understand how to best use all the resources we have to address that. Is AI making a difference in climate change, Lila, knowing that you are one of the few experts out there that combine both technology and climate science?
Yeah, this is a great question, and it's starting to make a difference because it's really important for us to understand how we're using our resources. And if you're a company, for example, you actually need to understand what's in your supply chain. I mean, how much carbon are you actually using? Just to stay with something really simple. But then in more complex way, how much risk are you exposed to because of your supply chain or because of the properties that you own and the buildings that you have, for example. All of that is now, of course, is starting to get affected by AI because AI not only can take into consideration all of those different data points, it now can run predictions and models to help you understand how much risk your company is exposed to, how much carbon is in your supply chain, how can you create redundancies, how you reduce it. So this is the first piece of that, is recording, understanding, reporting. But what's really exciting is what's coming down the pipes. You mentioned algorithms for protein folding. The AI algorithms that are now becoming more and more potent have the promise, the potential to help us actually discover some of the chemicals or some of the different ways for us to create materials that could embed carbon or catalysts that will help us sequestrate it. Because we know already today, if we wanted to recapture all the carbon, there's not enough soil on Earth to actually plant enough trees to do that. So we do need to science it. And in order to science it, in order to accelerate deep science, we actually need AI. And we're starting to see that with these basic models for understanding how two proteins attach to each other and how they form basic structures, and down the line, hopefully, for new chemicals, new materials, new catalysts.
Fantastic. But there's another side of AI and climate change, is the impact of AI on climate. Jacomo, it's been a lot of debate lately on the impact of large models, environmental impact. Are there any sustainable approaches that go deep into technology stack rather than just focusing on one layer of it?
I mean, it's a good point. I think and it's something that's attracted a lot of public scrutiny, which is that more and more of the, let's say, state-of-the-art models for a range of different tasks, across NLP on the one hand to vision to and again to even time series modeling are things are moving to larger models, and these larger models, just in virtue of having more hyperparameters, mean that they have larger compute requirements, and so there is a valid concern at the level of the compute cost that this represents and implications for for energy consumption. But I think it's a little bit that focus is I think a little bit misplaced. I mean, anytime that you have one of these like new state-of-the-art architectures, like it was GPT-2, and then after with GPT-3, you have a number of people who are able to basically replicate the performance, but to instantiate that in much smaller models. And that in and of itself is, I think, a really nice result, and not just from the compute perspective in terms of the carbon cost of it, but also in terms of the accessibility and consumability of those models for companies, let's say, that aren't OpenAI. I think that one of the things that we should be paying more attention to is maybe, the point that Lila was making, which is at the level of AI's ability to basically, move the needle on how we can optimize things in the physical world. As one example, for the last a little bit more than 1 year, we've been working on building a reinforcement learning bot, a deep reinforcement learning bot for steel production planning. So this is a heavy industry, very energy intensive, and to be able to do something which is going to sequence orders, and ultimately this amounts to producing steel that has very different requirements to it by composition, by geometry, ultimately means that you need to optimizing that and optimizing how it's going to produce and what ordered is going to have massive implications for energy consumption. And I think the lift that we're getting from that technology is something that I think is the thing to focus on. And there's other companies like Carbon Re that are looking to do this in cement, but how AI can, I think, shape the physical world. And the other thing that I would call out, and this is very much at the vanguard of a lot of deep learning. Just since 2015, there's been a number of advances around geometric deep learning, and geometric deep learning is basically taking think of CNNs and what they did for solving 2D image problems, like image recognition problems, and applying that to 3D geometries. And now we're in a world where we can basically accelerate a lot of multi-physics simulation using deep learning. And not only is this much less, let's say, less HPC intensive, so much less compute intensive to run these things. So that's one nice thing. But the real opportunity there is the opportunity to be able to optimize things in the physical world, whether it's a plane wing, whether it's the packaging for an electric vehicle battery, whether it's a wind turbine or a hydro turbine. I think that is the more hopeful thing about like the advent and the pervasiveness of these technologies.
And having the ability to learn from other domains and bring it back into the field of AI, I think is absolutely critical. But going back to the field of business, both of you, what are you most excited about when it comes to AI really delivering business performance, optimization, revenue growth? One or two use cases or examples you've seen that you're most excited about and you think that this one is going to make a massive breakthrough in business?
I can take the first one. If you look at what's happening, especially in the Western world, we're actually in the situation where in many Western countries, we are facing a situation where we're going to have fewer children than adults. And as a result, that is the productivity per capita needs to increase dramatically. How are we going to do that without having better tools to assist us? And I think that AI as an assistive technology, as a partner, is really, really important. So in the last 20, 30 years, we've seen every company turn into a digital company. I think in the next 20 years, we're going to see every company turn into an AI-powered company. In order to do that, we're going to need engineers. We're going to need people who are able to use AI, work with code. And I will tell you, a couple of years ago, we noticed on LinkedIn that companies that are non-tech companies are actually hiring more engineers than the companies that are technology-based by nature. So what are these companies to do? How do they compete for this talent? Which means that actually technology needs to help build more technology. And what we're seeing today with tools like Copilot is that we actually can help engineers build their code. So with Copilot today is about 30 to 40% of engineers' code is actually written by AI. And that number is going to continue to increase, meaning it's going to help every company become more effective over time.
Super. Jacomo.
I think that's exactly right, that every company is going to become like a form of an AI company. I think one of the most exciting things is the way in which that's starting to happen, which is that I think there are more and more ways in which the tooling that's allowing companies to consume and adopt AI is increasingly like right sized for many different kinds of companies that are composed of people with very different technical profiles. And so whereas just a few years ago it was very much a monolith, you needed to get people who were deep practitioners, whether it's at the level of managing the infrastructure around ML systems, or just at the level of data science, or people who could transact in like the data engineers who knew how to build these big ingestion backbones. And we're now, I think, in a world where companies have more and more choices. That I'll give a couple of specific examples. There's the sort of big competition, global competition for building recommender systems and evaluating the performances, like the Rexus competition, run by ACM. And for the last 2 years, at least in 2020 and 2021, NVIDIA's Merlin team, and there's something called like Merlin framework that has won the competition. So it's been part of the winning solution. And the thing that's just to take away from what Merlin is it is a framework that has, basically replaced what would otherwise have been, hundreds of thousands of lines of code that teams developing a recommender system would have to put down and implement themselves to, a few dozen lines of high-level API code. And that's just one specific example as it applies to recommender systems. But there's some of you may have heard of platforms like Robot and H2O. Microsoft with Azure ML Studio is building a suite of different tools, and all of them are just a little bit different. But you have more and more end-to-end platforms. And more individual components that are making it easier for companies, both I think to build ML systems that are fit for purpose to deploy into even mission critical applications in ways that are more risk assured. And on the other hand, to be able to do it with talent that is maybe a little bit more accessible to them. And so they don't need deep practitioners in a specific area of data science, a certain ML method, in order to be able to build models that use those techniques, whether it's deep reinforcement learning or deep learning writ large, just because a lot of that is sitting behind components, is sitting behind services that they're configuring. So it's much more a form of software engineering.
Well, hopefully at some point you'll be able to talk to the computer just like we're talking here and ask it to do things for you. This is where we're going, right? We started with bits and bytes and zeros and ones, and the level of abstractions of language is coming to the point where it's like human language. So, I can ask a computer to draw me a picture. I can ask the computer to go and find how many pictures are there of the three of us in a video link, things like that, right? And it's just going to be human language.
And I wonder if your examples, the fact that we are now tagging AI as a software engineer problem, doesn't aid with demystifying AI, which, because it was so specialized, creates a little bit of this is a domain that not many have access, but democratizing it allows us to really understand that is software development. So is AI just simple, plain old IT?
So I don't know that on the one hand, that we're getting to a place where a lot of the development, as Lila was saying, is moving up the abstraction ladder. In some ways, that's improving the accessibility problem. It's making, let's say, the developers more productive, more code productive themselves. They need to put down less code. And for organizations that are maintaining these things as live systems, that's less technical debt. So that's all great news. At the level of whether or not it demystifies any of this, I think that it might, there's an argument to be made that it actually exacerbates the problem. Like I might have my Samsung Galaxy phone, right? And there's no sense in which I can look at that phone and understand what's going on under the hood. And a lot of the people who are consuming these technologies really at the level of applications, but even the developers themselves, more of this is sitting behind complex services where it's actually hard to understand exactly what is happening behind this. At the same time, if you think about the move that I mentioned before for a lot of models moving, going towards larger models. These larger models we've known since the first version of BERT, with 110 million parameters, that these things are hard to train. In fact, some of you might remember a paper by Facebook a few years ago, Roberta, and it was basically not doing much at all to the architecture itself, but really improving the performance just on the back of how they were able to train that architecture. And the moment that we're in a place where we have billions of parameters and even like verging on 1 trillion parameters, we're in a world where this is extremely difficult to do, which is why, again, Facebook with its opt model just a few weeks ago published Chronicles, which is a little bit like what Hugging Face did with its big science project, which it published the recipes by which you train these models. But I think over time, this is something that's appropriate at the level of documentation for researchers. For people who are developing, enterprise applications, organizations that just want to do the development and use these things, ultimately, though a version of Chronicles is going to sit behind software routines. And now at the level of someone who may understand a whole lot less about machine learning, to begin with, and is now using these services even to train these models, I think it might make it even more difficult for them to understand really beyond the documentation what is happening under the hood.
It's not just about what powers AI adoption in the enterprise. It's about the constraints that are coming down the line. And I want us to touch a little bit the upcoming regulation that will come in force for various jurisdictions. First is European Commission with the famous AI Act. How will that change the dynamic of adoption in the enterprise? It's first question. And secondly, looking globally, a lot of companies like ours operating globally will have a bit of a challenge to harmonize different regulatory requirements coming for different parts of the world and being able to bring it under the same umbrella. So how do you think, Jacomo, AI Act first will change the way AI is going to be adopted in the enterprise?
So there is an argument to be made that maybe it won't change things all that much, right? Because a lot of, let's say if you think of like some of the higher risk settings, and there's sort of a pyramid of concern and risk of application, but in places like the medical devices industry, in aviation, in the automotive industry, the regulatory bodies already exist. And in fact, what you've now done is, just made nominal adjustments to documentation requirements and to understanding a little bit like what specifically are the testing and validation requirements for these kinds of systems. But there may not be all that much change for those specific sectors. I think there's much more of an open question for enterprise that are looking to build things in the way that we just described, right? In the way of like I'm using, let's say, components and services within, let's say, Azure ML Studio. I'm, using some other platform, which is now where there are a number of things happening behind a service, and I think those questions are going to really have to query whether or not bringing in these things into a specific application, into a specific model and system, will meet those requirements. But I think. Where there are questions, the AI Act is also provisioning the creation of sandbox environments in which to be able to test and experiment. So there's also that.
So you're hopeful it's not going to impact as much. But what about other regulation? How does the world of Microsoft sees this moving ground of regulation around the world?
We actually see regulation as an important component of a healthy ecosystem. In general, and we see regulation in privacy, which is very important, and we actually supported regulation in AI, which we started working on years ago, and setting up some criteria for what AI should do, should look like, and should act like. And because AI is fundamentally, and we were just talking about what's actually happening, these models are getting bigger and bigger, they're getting better and better, of course, but they're getting less and less explainable as a result, because none of us, not even the best AI scientists can hold the entire model in their heads. That's the power of AI, that it can look at, combine, and be trained on so much data that no single one of us can replicate that. What does that mean? That means we don't fully understand it. So how do we interrogate it? How do we understand how it's going to behave? What kind of biases are going to be embedded in the system, especially if this is going to be used in mission-critical applications? What are the failure modes of these? These are the kind of testing requirements that I need to get, and testing harnesses that are going to need to be put into place. And regulation can help that, and can help actually create some harmonization if the legal makers are actually talking to each other. So earlier this year, I was supporting a couple of work streams with OECD, specifically around how to think about AI, how regulators should think about AI, and how they should collaborate so that we don't have one regulation in one country, another in another country, and we have some harmonizations across them, and also some harmonization across the providers. Because some of the things that are happening today with just plain data is that it's so difficult to take your data from one system and put it in another system that it's a blocker for you as a customer, for you as a company.
So you're saying it's really important for the regulators themselves to collaborate before they impose any rules on all of our companies.
Yes.
There's on the one hand, you want to have this, this multilateral coordination. On the other hand, I think it's a pretty savvy move on the part of the European Union to say, to act quickly, and then there's an argument to be made here that there's a first mover advantage that it has in enshrining that its standards are going to be the ones that are going to be adopted. Like if you take LinkedIn as a specific example. A lot of the things that, even at the level of how job placement adverts are made, like to the sense that these things are model driven, then, or even at the level of a market making mechanism between people who see listings on the one hand and people who are recommended for those profiles, like these things are model driven, but to the extent that it is a single platform, I think it's very unlikely that ultimately Microsoft will, and I don't pretend to know anything at all about what Microsoft are doing in that respect, but that they will look to split these things out and to have an EU version and a non-EU version. I think in all likelihood these things will basically look to abide by EU standards, and that's at the level of the global platform. So I think it's a good move for the EU to try to sort of codify values and standards that it would want to see more broadly by acting more quickly than others.
Although I've heard voices saying it's not going to have anywhere the impact GDPR has had, but remains to be seen. I know time is flying really fast and I have plenty of questions for those guys, but I'll give you the chance in a minute to ask some questions, so prepare it. One more question from me. Lila, you touched briefly on areas where AI can fail. Are there more examples of concrete failures? We're not talking about existential risk that we should be aware, and we've discussed in the panel before us talking about bias, but on top of it, are there any engineering type of problems that are massive risk when it comes to AI, and how should they think about approaching mitigating it?
Well, massive risk that's a question in general for software, right? It's not an AI-specific issue. It's just as our systems become more and more digitized, they are more accessible to security risk, and we see this. Microsoft is the largest security provider in the world, and we see this as that risk grows. And it grows exponentially as more and more of our world becomes digitized. But I think I want to give you a really concrete example of where AI fails, not because AI itself fails, but because sometimes we fail to understand how we, as humans, interact with each other and interact with computers. So you probably all know really great systems called Teams. It allows us to talk to each other online. It translates if you speak across different languages. So I can speak one language, you can speak another language, and we can understand each other. It will summarize, it will transcribe, all these amazing features that will record you. Well, when we build these features, one of the things that we do is we put it through an ethics review. And typically, engineers, they would want to turn the new hot AI feature on immediately. And that's when the design ethicists will come in and they'll say, oh, let us evaluate how people actually interact with each other. So the research team will come in and will say, well, if you turn the recording button on and transcription on automatically, what turns out is that actually people who are already a little bit marginalized or there's already bias there, so if it's a woman, if it's a person of color, they will actually, there's a chilling effect. They will not speak up. So when you're faced with that, you actually need to think about how to build the product in such a way that people can utilize the features without having the harmful effect. In fact, create a more inclusive environment for them. So we've worked super hard. We've held the feature, in fact, for a little while, until we figured out how not only to mitigate, but to create a more inclusive environment. And those are the areas where if we are not careful, we can make things much worse for the world that we want to see. So it's very important for us not just to jump on these incredible things, but to really, really understand and design for the world that we actually want to create.
Perhaps we also need to be rethinking, reframing AI as not just a GPT, general purpose technology, but a socio-technical system, as NIST has recently stated. I have more questions, but I want to pass it to you guys. And who wants to ask for a question?
Oh, yeah.
Any questions?
Hi there. Thanks for the wonderful panel, fascinating discussion. I build AI products myself, so this was very fascinating. One question I have for both of you is, yes, the panel is how to adopt AI and businesses adopt AI. Have there been examples where either you said in your capacity, no, you shouldn't do AI, or have businesses come to you and said, we want to transform this with AI, and you've said no? So do you have a stance like that? I know you can't give specific examples, but because I build AI, I see AI everywhere, right? But there are instances where you can draw the line and say, no, AI shouldn't be there.
Absolutely, absolutely. We've done it many times, in fact. And that goes back to the AI principles that we laid forward several years ago now. So I can give you an example. So as you probably know now, you can synthesize voice and you can synthesize appearance of a person. And we absolutely said, no, we will not make that technology available. Because it's obviously you can make deep fakes, you can create a lot of negative effects with that. It's just not something that is worth putting out there in the world, because our harms assessment framework told us no. That's an incredible technology. The AI was breakthrough, and we don't ship it.
I mean, in the context of the work that we do, it'll be more at the level of how these things should be designed. I mean, I think it's rare. I mean, I haven't seen any individual applications where, let's say, whether it's in the public sector on the one hand or private sector company outright trying to do something which is like looking to do harm, right? Some of you may have seen the Science paper just a few months ago, like where Collaboration Pharma was trying to took basically this is software, ML software that's looking to search a space of compounds in order to be able to meet some kind of objective. And what they did was this pointed at the space of nerve agents. And in roughly like 6 to 7 hours, they came up with about 40,000 compounds, many of which were like known nerve agents, including VX. So like there are very few, and all of that is in the context of that paper saying that a lot of the technologies that are looking to do good, right, which can be pointed at problems like discovering new small molecules for rare disease treatments. On the other hand, can be pointed at things that are actively looking to do harm. There are very few examples, I think, of companies that are actively looking to do that, but it's more a question of how to design them well and in ways that meet requirements, will have not lead to unintended consequences in the way that Lila described. And there, I think it's good to, we talk a little bit of AI as a monolith. I think we all recognize here that we're talking about many different techniques and methodologies. And in many cases, when we think about designing, it's not a question of just meeting a problem, but also meeting even certain compliance and risk requirements. So you might very well pick a technique that could come at a small handicap in terms of performance on a relatively simple task, but means that it's intrinsically more explainable. It's easier to be able to understand like the marginal importance of different features, and this is something that is ultimately, perhaps because of the way in which it's going to be consumed by the end user, right? And so it's more a question of what are the right ways in which to design these things, at least in the way that I've seen it.
And this is where we see the role of ethics of AI, my field, in helping us understand the consequences, both unintended and intended, but also how do we able to understand the impact and translate it into design requirements, into controls to manage risk. And I can't stress enough how much we need ethicists to work alongside technologies to understand those type of problems. Any more questions? We have a microphone over here, please.
So taking that theme and trying to build in a positive way, one of the things that really fascinates me is why it is that we're now besieged with fake news. Why is more and more of the facts which we are consuming, particularly sometimes in LinkedIn, some of your own projects, are wrong? And it would appear to me that there is very little clearly evolving to check facts in the media. It can't be that difficult. Many of them are binary. They're simple things which you could automate. And I wonder how much work is going on to do this and how much work is being, if you like, distilled by business, where obviously the more erroneous and provocative facts drive advertising revenue.
Excellent question. Who wants to take it? Lila?
So I think this has to do a little bit less with AI and has to do more with social media and how people actually interact with each other and how they interact online. In my past life, I was I had the privilege of being in charge of a little website, running the organization behind a little website called Wikipedia. And Wikipedia had near zero at the time, near zero AI on it, and yet the only reason that Wikipedia actually became and then stayed fairly high quality in terms of news factors is because it has very clear parameters of how people were validating those news. Very similar thing is actually happening on sites like LinkedIn and on our gaming and all of our publicly facing sites today. There's actually, yes, there's AI application today to verify that the news are actually correct or the information is actually correct, or that the information is, or that the conversations are positive, right? So that we take down materials that are obviously harmful or illegal, right? All of these applications of AI are already in place today. They're not perfect, unfortunately, right? Because there are situations where it's a humorous thing, right? So you have to understand the intent, and AI is not there yet. These tools are not there yet to understand it in that depth of a detail, right? Sometimes it's a joke. Sometimes it's an imaginary thing that people are trying to process. You don't always know if it's a correct news. And LinkedIn obviously is not a news channel. It's a sharing environment. Now, if we go and point at that news, that's a very different situation. And there, you actually need to go all the way down to what is the primary source? Like, who was there with the camera, and what that footage was actually the real footage? Because now we can even fake that.
I think the question is an excellent one. I think you're right. Like there isn't. It's already a problem, and a problem of like significant scale, and it's a little bit at the level of these bots that are amplifying certain content. But by and large, a lot of the content is not used with ML, and I think you're right that there could be, let's say, more ML that's thrown at the problem of mitigating the problem. Right? or the severity of the problem. But I think, and this is maybe like where I'll strike a little bit of a pessimistic note, I think the problem, as bad as it is going to get like incredibly worse in the next few years. Because if you think about GPT-3, and like we're now in a world not just at the level of language, but also at the level of video and images that we can synthesize things that have no bearing in reality whatsoever. And so now in a world where these bots are just generating a lot of the content, what are the ways in which we really tune these platforms? Because I think ultimately it's a question of the design of these social media platforms. And there I don't, as Lila was saying, I don't know that it's a question of trying to solve the problem strictly with AI and ML. I think it's much more at the level of maybe curtailing the problem, the level of recognizing that, speech on these platforms needs to be regulated, but that you would regulate speech very differently when bots are the sources of that speech versus individuals. Like these, and I think a number of people have made that proposal that it should be really at the level of identifying, validating identity, and that has a host of other issues as well. But I mean, I do hope that we make a whole lot of headway in tackling that problem, because it's going to get a whole lot worse in the next few years, I think.
Unfortunately, time is running out. We only have 2 more minutes, and I want to ask you one last question. We focus mainly on the positive side, as it should
Mainly.
be. Mainly. But thinking of the immediate future, what makes you even more optimistic about the prospects of AI in business, Lila? 1 minute each.
For me, it's starting to see it across everything that we do and helping us in our lives. It's very, our lives are busy, we're doing way too much. We could use another pair of hands, and those hands could be AI hands, which are starting to help us. It's starting to happen across the platforms. And for tomorrow, I am extremely excited about what AI can do for us in terms of helping us solve problems in health, helping us cure diseases, and climate, helping us restore our planet, and in science in general.
Thank you. Brilliant.
I'm extremely optimistic, about the general direction, like the pace at which a lot of these technologies are evolving in a few very specific ways. Like the move to these, some of the kinds of foundation models, whether foundation models around NLP, around vision, like the move to even these multimodal models, like these are really impressive capabilities, and capabilities that we couldn't even imagine just a few years ago. Like if you think about like DeepMind's Gato and having a single model that trained on such a broad range of tasks, whether it's robotic control to playing Atari to solving NLP tasks, like it is just strange that we're in a place where I think we recognize now that we still don't understand at what point, we are certainly not in a world of diminishing returns for these large models and these architectures. And that, I think there's something intrinsically hopeful about that, in that these things can solve incredibly hard problems. And the set of problems at which they will be pointed, I think there's an obligation on all of us as maybe as developers of these models and systems to point them at the right set of problems. But I think we have technology increasingly that is meeting like the size of those challenges. And I think the other one is something that we touched on at the very beginning of this session, which is at the level of changes at the level of tooling that are making ultimately this technology a whole lot more consumable for a broad range of organizations. And I think that's also incredibly helpful, because there's a lot of organizations, heavy industries, carbon-intensive industries, organizations that aren't full of engineers, DevOps engineers, machine learning infrastructure engineers, data scientists, but that could do with consuming this technology. And increasingly, we're in a world where they don't have to hire a whole lot of other, a large cohort of developers that aren't among their ranks. Like increasingly, the tooling is fit for purpose for the kinds of organizations that they are.
Thank you. That was brilliant. I can continue for the whole day and tomorrow, but we know we have to leave the stage. Join me in with a big round of applause to Lila and Jacomo.
Thank you.
And enjoy CogX.